I know, I got to have them be totally public. Okay, let's start with this. F of g of 2. So what's g of 2? You go to 2 and you find that it's 1, see? So you're really doing f of 1. And what's f of 1? 1. That's how you do it, right? You use the g function first, then you use the f function to find out your output. All right, let's start over. What's g of negative 2? So I go over to negative 2 and I find, okay, it's 2. Then that means I have to do f of 2. And what is f of 2? 4. There we go. Okay, so there's 2 like that. Now there's 2 where you go the other way, where we start with the table and then go to the graph, okay? So let's start with f of negative 3. What's f of negative 3? Cool. So then we look for g of negative 3, which is 3. So we have our answer overall of 3. Okay? F of negative 2 is 0. So we're finding g of 0. And what's g of 0? 0. Perfect. It goes through the origin. Good. Okay. There are questions like that on the final. That's why I made this warm-up. Okay? What's f inverse of 4? Good job. Because you find where is the output 4. You're looking in the output section. So the output is 4 right there, and that means the input is 2. Okay? Did you say I don't get that? F inverse, remember, F inverse is when the y's and the x's flip. So when I say F inverse of 4, I'm really asking what input gives an output of 4. Okay? So that's like when I ask the next question, when I ask g inverse of negative 1, I'm saying what input gives an output of negative 1? Exactly, because there's the output of negative 1. 1 is the one that does that, right? And there's questions like those two on the final as well. Yeah. Why is C3? Oh, because look, at g of negative 3, when you go over to negative 3, the function is up here at positive 3. So the output, when the input is negative 3, the output is 3. Okay? Find x such that f of g of x equals 2. This is a really hard one, and our team decided to put one like this on the final, so I wanted you to see one. Okay? Hey guys, it's not up to me completely. I put it all together, but it's this partly up to the team. Okay, so here's what we have to say. F of what equals 2? I want to be able to see everything though at once, so hang on. So f of what equals 2? And the answer is negative 1. So that means this inside is negative 1. Do you agree or no? Is that okay? Because we're saying what input gives me an output of 2? That means that g of x equals negative 1. Do you follow that? Because it's like saying, look, it's saying f of something equals 2, and that something is negative 1, so g of x must be negative 1. So then x is 1. Good job. Because what input gives an output of negative 1? It's 1 from looking right here, see? At an input of 1, you get an output of negative 1. Okay? I can do more of those in the coming days so we can keep practicing that idea. But it's f of something equals 2, and then that something gives us an input of 1. Okay, number 2. Suppose a $29,000 car loses value at an annual rate of 9%. So everybody write R equals 0.09. Write a function y equals ab to the x to model the value of the car after x years and use it to determine the value of the car after 10 years. Okay, what's A?
29.
Good job, 29,000. What's B? 1 minus 0.09. Good job. So what is that? Thank you. 0.91 raised to the x. Is everybody cool with how he got that? The B value is 1 minus the rate when we're doing decay. And this is decay, right? It's losing value. So this is the deal for decay. What's the deal for growth? It's 1 plus R. That's for growth, okay? So now when we plug in 10 years, 10 goes in for x. So it's 29,000 times 0.91 raised to the 10. Let's go to the calculator. 0.91 raised to the 10. And the value of the car is 11,293.
Wait, then when you use like the 1 plus R for X?
That's when you have money invested in an account.
Just money?
Like if it was like compounded monthly.
Oh.
And if N is 12, then that's when you're going to use that thing.
Oh.
Okay? So that's what it's worth. Anyone have any questions there? Okay? All right, log A is 4, log B is 2, log C is 3. Evaluate that big mess. Any ideas?
Oh.
Yeah?
Do you do 3 times 3 to the third power, which is
No,
okay.
because this doesn't say that C equals 3. This says log C equals 3. So we have to break this apart. Nope. So we're going to break that apart with using properties. So remember, what does division lead to with logs? Right. So I can call this log of C to the third A minus log B. Yay, we're getting somewhere, right? Because now I have it split apart. Now I can substitute 2 in place of log B if I want. I'm going to do 2 more steps, though, before I do substitutions. Okay, so what does multiplication lead to in logs? Good, so we're going to write this as log C to the third plus log A minus log B. Now we're almost ready to finish. What do I do with that 3? What do the properties tell us I can do with that 3? It can come down in front. Remember that property? We're going to need to study those properties again. So 3 log C plus log A minus log B is what we need to evaluate. All right, now what is log C? 3. So this becomes 3 times 3. What is log A? 4. And what is log B? 2. So it's 3 times 3, which is 9, plus 4 minus 2. What is that, 11? 11. So the answer is 11. There's one like that on the final, too. You're so lucky that I'm the team leader because I'm thinking about the final all the time. And so whenever I'm making warm-ups, I'm like, oh, I got to give him one of these. I got to give him one of these. So that's what I'm doing. So we'll keep doing these over and over again, okay? Finally, evaluate tangent of 5 pi over 3 without a calculator. Where the heck is 5 pi over 3? Yes, Veronica. Good job. Is it close to the y-axis or is it close to the x? No. It's this spot right here. Close to the y. This is the y-axis. It's closer to the y-axis. So now make your triangle. Okay. It's in the 30, 60, 90 family. So what should I label this top side? 1/2. That's the short leg. Good job. And should it stay positive? Yeah, because we're moving to the right. What should I label the downside? Good, but it should get a negative. You agree? Okay, but I asked for tangent.
So it's side of cosine.
Good. So is that y over x or x over y?
Y over x.
Good. So negative root 3 over 2 divided by 1/2. Keep change flip, right? Negative root 3 over 2 times 2 over 1. What happens now? Sure. Or I can just cancel the 2's to begin with, right? 2 over 2 makes 1, and my answer is negative root 3. What am I going to say? There's one of those on the final, too. So this is a great study guide over a bunch of different topics that, yeah, there we go. And these are also covered in the packet, of course, too. So you can practice in there. So.
Is there like a, what's it called, a key to this?
I'm going to make it over the next couple days and post video solutions. Okay? All right, good, cool.